Okay, so the class is being recorded now. You can put your attendance. Okay. So because of some personal reasons, I couldn't take your class on Monday. So we are continuing your class on today or on Wednesday. Okay. So I had given you notification regarding your test. So be prepared with your complete syllabus. You're going to be giving lots of tests in the upcoming month. Okay. So keep studying, keep revising. Today also we are going to revise one of the chapter from our Science 1 syllabus. So today I'm thinking about going with a different method. Okay, we are not going with a conventional method. So what we are going to do today is I'm going to present the screen to you, or I'm going to present the book to you, and every one of you is going to explain me and other student the concept. Okay, जो concept दिया है यहाँ पे मैं जो स्क्रीन पे दिखा रहा हूँ वो आप लोगों को मुझे और बाकी सारे स्टूडेंट्स को समझाना है, एक्सप्लेन करना है इन 2 minutes or 5 minutes. Okay, so everyone is comfortable with this? Okay, Tanvi is comfortable. Very good. So today you are gonna teach all of you. Okay, I'll be helping you. Okay, Bhairavi is there again. What about you, Laksh, Atharva, Arshad, Amar, Om? Okay, Atharva is again ready. You can't explain in laptop. You can't give that reason also, Laksh. Why you can't explain in laptop? I'm using laptop only. I'm using PC instead. Okay, don't give reasons. Laptop is having microphone, so you can explain. Okay, at least you can read the paragraph. So without wasting our time, let me just present my screen, and then I'll show you which chapter we are going to revise. So the chapter is easier one, so that you guys can explain this. Okay, now see, this is our chapter 7, lenses. This chapter we are going to revise today. Okay, so yeah, we'll not start with Tanvi. uh, Laksh, you are not able to explain because of laptop, but that's not a good reason. What about you, Amar and Arshad? You guys didn't give any reply. What is the problem with you guys? Amar, and you don't have a book. Okay, you don't need to have book. तुम्हारे पास book होने की जरूरत भी नहीं है. Can you see my screen? You just have to look into the screen, read the paragraph, and explain it. Okay, good. So first of all, we will start with Amar. Amar, please turn on your mic and you can explain what is lens or what is lenses. Okay, so जो पहला paragraph है, lens exactly होता क्या है, you can explain in English or Hindi as per your convenience. You can turn on your mic now, Laksh. Sorry, Amar it is. Amar, go ahead. You don't know what is lens. Okay, that's fine. But at least you can read the paragraph, don't you? You can read the paragraph. So you can read. Please turn on your mic and read the paragraph. Yeah.
You must have seen lenses used in day-to-day life. Some examples are the lenses used by old person for reading lens embedded in the front door of the house. The lens which the watchmaker attaches to his eyes, etc. Lenses are used in spectate. They are also used in telescope as you have learned in the previous standard. A lens is a transparent medium bound by two surfaces. The lens which has two spherical surfaces which are puffed up outwards is called a convex or double convex lens. Spherical on the inside is called a concave or double concave lens. This lens is thinner at the center as compared to its edges.
Okay, sorry, I just forgot to turn on the mic. Okay, so what is lens? Lens क्या होता है? Lens is nothing but a portion of spherical uh, spherical or your sphere, okay, transparent medium bound by two surfaces. So if let us suppose the two surfaces of a lens are puffed outwards, is called convex lens or double convex lens. Okay, so this is double convex lens. And if the surfaces are like this, they are inside like this, so this is called a concave lens. Okay, so these are the two types of convex lens as well as concave lens. Now as you can see, here are few lenses given, few examples of lenses are given. So biconvex यानी कि दोनों तरफ से इसका जो सरफेस है दैट इज कॉन्वेक्स है, मतलब बाहर की ओर निकला हुआ है. नाउ प्लेनो कॉन्वेक्स, दिस इज पॉजिटिव मेनिस्कस, bino biconcave, planoconcave, and negative meniscus. So these are the types of the lenses. So some of the portion from your syllabus is reduced, I know that, but still we are going to revise that because we have learned that in while we were taking lectures. Okay, so if you learn something extra, so that is not bad thing. Okay, so see, कॉनकेव लेंस, कॉन्वेक्स लेंस किस तरह से बनती है, लाइक दिस, एंड कॉनकेव लेंस किस तरह से बनती है, सो लाइक दिस. सो दीज आर द टाइप्स ऑफ कॉनकेव as well as convex lens. So I hope all of you have clear concept of what is concave lens and what is convex lens. You should not be confused between these two. Okay, okay, good, very good. So okay, Krish has joined today and he has changed his name as well. That's very good, Krish. Okay, now these two or three definitions or concepts are there. So one by one, you people will elaborate the concepts. So first of all, center of curvature. What is center of curvature? Who wants to explain? Who wants to explain? Tanvi, do you want to explain? If yes, you can turn on your mic. What is center of curvature? Tanvi, can you hear me? Can other people hear me? Okay, Tanvi, you can start.
Okay, sir. The center of curvature. The centers of a sphere whose parts from surface of the lenses are called center of curvature of the lenses. A lenses with both surface spherical has two centers of curvature, C1 and C2. मीन्स की त्याच्यामध्ये असं सांगितलंय की जस आपला स्पेअर असतो त्याच्या सेंटरमध्ये त्याच्या सेंटरला सेंटर ऑफ कर्वेचर असं म्हणतात, जो दोघांना सेम पार्टमध्ये डिवाइड करतो.
ओके, ठीक आहे.
आणि जेव्हा जेव्हा दोघं बोथ सरफेस असतात तेव्हा मग दोन सेंटर होतात, C1 आणि C2.
Okay, fine, ठीक. So see, we have seen that a lens is made up of two spares. Okay, बरोबर, इथे बघा दोन spares होते. Here are two spares. Okay, and by using these two spares, we are making either convex or concave lens. So what is center of curvature? See, center of curvature, center of sphere of which the lens is part. See, this is a sphere and this lens is part of this sphere. So this center C2 is called as center of curvature. Okay, for this part, this is C1 is the center of curvature. तो अगर दो स्पेयर से मिलके कोई लेंस बनती है, so that is दो सेंटर ऑफ कर्वेचर्स रहेंगे, C1 and C2 as shown in this diagram. It is more, it is self explanatory. Okay, इसको अगर आप देखते हो तो ही आप मतलब देखते ही समझ में आ जाएगा कि व्हाट इज सेंटर ऑफ कर्वेचर. नाउ रेडियस ऑफ कर्वेचर, व्हाट इज रेडियस ऑफ कर्वेचर? सो हु वांट्स टू एक्सप्लेन रेडियस ऑफ कर्वेचर? See, these are very easy concepts, but I just want you people to speak. That's why I'm telling you to explain the things. Okay, once you explain the things, you never forget that. Okay, So that's why I'm just taking your practice. Who wants to explain radius of curvature? Just put your names quickly. It's not that hard, okay? Nobody wants to explain. See, as simple as that. If there is a one sphere, or let us suppose circle here, so if it is having a center, it must have a radius. उसकी कुछ तो रेडियस तो रहेगी ना. अगर एक कोई स्पेयर है या फिर कोई सर्कल है तो उसकी एक रेडियस भी तो रहती है. So that radius is nothing but radius of the curvature. मतलब कि देखिए this portion R2 is the radius of this curvature or this sphere, like this. Okay. Now next one is principal axis. The imaginary line passing through both centers of curvature is called principal axis. Principal axis of the lens. So here two centers are there, C1 and C2. Okay, C2 is here and C1 is here. So the line passing through both centers. So this is called principal axis, as easy as that. Optical center, the point inside a lens on the principal axis through which light ray pass without changing their path is called the optical center of the lens. In figure 7.4, rays P1Q1, P2Q2 passing through O are going along a straight line. Thus, O is the optical center of the lens. तो अगर आप इसे हिंदी में समझाना चाहेंगे तो कैसे समझाएंगे कि एक ऐसा पॉइंट इनसाइड द लेंस के अंदर एक ऐसा पॉइंट होता है जिससे अगर कोई लाइट रे पास होती है so it doesn't change its path, it goes straight. Like see, P1 is going straight through this like this and P2 is going this way. So this particular this point is called as optical center, which is represented by O. Principal focus. Now what is principal focus? When light rays parallel to the principal axis are incident on a convex lens, they converge to a point on the principal axis. Okay, they converge to a principal axis. This point is called principal focus of the lens, as shown in figure 7.5. F1 and F2 are the principal foci of the convex lens. So देखो यहाँ पे दिखाया है आपको. This is principal axis. Now what is principal axis? I don't need to explain that. Okay. So if a ray is parallel to principal axis, so after changing its path, it gathers somewhere. Okay. See. Okay. The rays are gathering at some point, and this point is called as principal focus. Okay, this is called as principal focus, which is denoted by F. And for the concave lens, so this was for convex lens. For concave lens, if rays are parallel like this, so they'll be transmitted like this, but its projection will be like this, and here we will get the principal focus. Okay, like this. And vice versa. If let us suppose the rays are passing through the principal focus and then they are striking on the lens, so after striking on the lens, they will be changing their path parallel to the principal axis, like this. Vice versa. मतलब अगर rays parallel है, they will pass through principal focus, and if they are already passing through principal focus, so after changing their direction, they'll be parallel to the principal focus. So these are the concepts. Now focal length. अभी focal length की concept कौन समझाएगा? What is the focal length? Very easy concept. Who will try focal length? Definition is in front of you. You can just break that definition, or you can just translate that definition into Hindi and you can explain, or even in Marathi. Nobody. Let me just know how many of you are present here. Everyone is present? Put yes in the chat box. Okay. Okay. Almost everyone is present here. Good. So why you can't just Atharva, you just turn on your mic and tell me what is principal focal length? Atharva, you just turn on your mic and tell me. Okay.
The distance between optical center and principal focus of lens is called focal length of the lens.
Okay. See, this is optical center and this is principal focus, isn't it? So the distance between these 2 points is nothing but focal length. Now the focal length is going to be very important for us going ahead in the chapter. Okay, so that's why we must understand what is focal length. Okay, that's it about it. So as I told you, here we have one convex lens and the ray is parallel to the principal focus. It is going through the, sorry, it is parallel to the principal axis and it is after reflection or refraction, it is passing through principal focus, that is f2. Okay, and if it is already passing through f1, then it must go parallel to the f2. And as we have seen, if it is going through the optical center, it will not change its path, it will go straight like this. Okay, so we had this experiment to do and here are the results of the experiments. So this is some results of the experiment. So everything can be summarized in this chart, and if we understand this chart table, then we will understand the all concepts given above. Okay, so I'll not waste time on the above concepts, we'll just discuss about the chart. Okay, now see, first of all I must tell you few things. See, this is our lens. Okay, let me just zoom in a little bit. So this is our lens, this is optical center. Everyone please understand. Okay, I'm going to ask questions to you only. This is principal focus, this is second principal focus, and this distance is 2f1 and this distance is 2f2. Okay, now what is 2f2? Twice the distance of focal length, now we must consider that we are putting the object on the left side of the lens, on the left side of the lens, and we are just observing where its image forms and what is the nature and what is the size of the formed image. Okay, so that is we are going to observe. So we are going to put the object somewhere between f1 and o, that is principal focus and optical center, or we are going to put the object between 2f1 and f1, or we can put the object beyond 2f1. Okay, so that is called as, and the last point, that is called as infinity. We are putting the object at infinity, which is far from 2f1. We must understand difference between these two. Putting beyond 2f1 and putting at infinity. Infinity means a lot more distance than this distance. Okay, and if we are putting beyond 2f1, that means we are putting like 3f on 3f1 or 4f1 like this. Okay, so these are the things that we must remember before going through the chart or the table. So first we are putting the object at infinity. Okay, so see, if I put the object at infinity, so its position of the image form, it will be at 2f2, sorry, it will be at f2. So iski image kahan pe aayegi hamari, f2 pe aayegi, and that image will be point size image, point image, and it will be real and inverted. मतलब image कैसे रहेगी, real रहेगी, लेकिन it will be inverted. Okay, this will be inverted. Now what is real image, what is real image and what is virtual image? Real image means the image that we can observe, okay. Now beyond 2f1, so we are putting beyond 2f1, we just put at infinity. Now we are putting beyond 2f1, sorry, it is not f1, it is 2f1. so its image will be forming between 2f2 and f2. मतलब इसकी image कहाँ पे form होगी, between f2 and 2f2, and the image size will be smaller than the actual object. See, I'm putting the object here. Now image will be forming between f2 and f1. It will be smaller, it will be again real and inverted image. मतलब मेरा object अगर यहाँ पे है तो इसकी इमेज हमें यहाँ पे दिखाई दी. Okay, so you can relate these things if you have used binoculars or some scope kind of things. Okay, scope में telescope अगर आपने use किया है तो mostly you get inverted images. So you must relate to the inverted images concept. Now, if we put the object at 2f1, see, we are putting the object right at this place. So its image will be forming on 2f2. 2f2 पे image form होगी and that will be real and inverted and the image size will be exactly same. It will be of same size. Okay, like this. Now, see, first of all we put at infinity, then beyond 2f1 and now at f2. Now we will put between 2f1 and f1. ठीक है, तो इमेज देखिए कैसे फॉर्म होती गई. पहले जब हमने इंफिनिटी पे रखा तो इमेज फॉर्म हुई f2 पे. हमने ऑब्जेक्ट और क्लोज लाया, थोड़ा सा क्लोज लाया तो इमेज थोड़ी सी इस साइड खिसक गई. ओके, सी नाउ इट फॉर्म बिटवीन f2 and 2f2. नाउ व्हेन वी पुट ऑब्जेक्ट एट 2f1 इमेज वेंट स्ट्रेट टू हियर. ओके, यहाँ पे चली गई. नाउ वी विल पुट बिटवीन f1 एंड f2. अगर हम यहाँ पे रखते हैं so it will be beyond 2f2. ओके, तो 2f2 के बियॉन्ड रहेगी हमारी इमेज, उसके बाद रहेगी हमारी इमेज. इट विल बी लार्जर देन द ऑब्जेक्ट, इट विल बी रियल एंड इन्वर्टेड. ओके, सो सी, जैसे जैसे हम ऑब्जेक्ट को क्लोज ला रहे हैं वैसे वैसे इमेज दूर जा रही एंड इट्स साइज इज अगेन इंक्रीजिंग. ओके, साइज इज अगेन इंक्रीजिंग. First of all, it was point size image, then it was smaller than the object, then it was same size as the object, and now it is larger than the object. Okay, so just remember the pattern so that your every concept will be cleared. जब concept clear रहेगी you can write in the examination, there is no problem, but you need to have your concepts clear. That is the main point. Now we put the object at f1. See, now we have come here. So where will be the image? Image will be at, position of the image will be at infinity and it will be very large, real and inverted. So see, f1 पे जब हम आ रहे हैं, पहले infinity पे ऑब्जेक्ट था तो इमेज f2 पे आई थी. Now f1 पे ऑब्जेक्ट है तो इमेज infinity पे चली जाएगी, not beyond 2f2. It will be at infinity. Its nature will be, size of the image will be very large and nature of the image will be real and inverted. It can be seen, that's why it is said real, but it is inverted. It is very large, so actually we cannot see it, but it is real image. Now we are putting the object between f1 and o, that is optical center. Okay, so see, now we are putting object here somewhere between this. So let us suppose a is the object, a object hai. Now on the same side of the lens as the object, तो इमेज कहाँ पे बनेगी इसकी? देखो, इसकी इमेज उसी डायरेक्शन में बनेगी या फिर उसी साइड में बनेगी जिस साइड में हमारा ऑब्जेक्ट रखा हुआ है. ओके, सी, वन रे इज गोइंग लाइक दिस, so it will be like this and it will be like this. So if we draw the projection of this rays, it will be somewhat here. जहां पे रे कन्वर्ज होते हैं, ओके, जहां पे रेज कन्वर्ज होते हैं वहां पे उस ऑब्जेक्ट की इमेज बनती है. ये चीज आपको समझ लेनी. ओके, हाउ? लेट मी जस्ट टेल यू. सी, लेट अस सपोज ऑब्जेक्ट इज एट इंफिनिटी. सी, दिस इज इंफिनिटी. सॉरी स्टूडेंट्स, sorry, I just accidentally left. Okay, so you must understand one thing, that image is formed at that point where the rays converge. रेज जहां पे कन्वर्ज होते हैं वहां पे इमेज फॉर्म होती है. जैसे कि मैंने आपको बताया, अगर हमारा ऑब्जेक्ट इंफिनिटी पे है तो सारे के सारे रेज जो है वो दे विल बी पैरेलल टू द प्रिंसिपल एक्सिस. ओके, रेज विल बी कमिंग लाइक दिस. Okay, see, rays are coming like this and they will converge at this point. So जहां पे रेज कन्वर्ज हो रहे हैं, at that point we can observe the image. यहाँ पे हमें image देखने को मिलेगी. ठीक है. So in this case, now object is where? Object is here between F1 and O. So see, this is the object. One ray goes parallel and another goes through the optical center. That is always true. And if we draw their projections like this, so they will be converging somewhere here. On this side, they will not converge or they will not meet each other ever. कभी भी यहाँ पे O मिलेंगे नहीं. They are converging here only. So what is happening here? The image is forming, but it is virtual and erect image. It is virtual image. We cannot see that, and its nature will be again very large. Okay, so these are the things about image formation using lenses. Okay, so I hope you understand the chart. Okay, good. Now see, that was about convex lens. Now this chart, this small chart is about the concave lens. So if the position of object is at infinity, so the position of image will be on F1, on the first focus F1. Size of the image will be point image and it will be virtual and erect. Now anywhere between optical center O and infinity, see optical center O के बीच में और infinity के बीच में अगर कहीं पे भी हमारा ऑब्जेक्ट रहता है, so image will be between optical center and focus, and the size of image will be small. It will be again virtual and erect. So image virtual कब रहती है? जब when the image will be virtual, image will be virtual when that is on the side on which object is placed. मतलब जिस साइड में ऑब्जेक्ट है, अगर उसी साइड में इमेज फॉर्म हो रही है, so that is virtual image. We cannot see the real image. So in case of concave lens, we always get the virtual image only. We don't get the actual image or the real image. So that is one more point you must observe. Okay, there is no condition that we can get the real image, is it? Good. Now see, sign conventions. So जब हमें प्रॉब्लम सॉल्व करने हैं, लेंस फॉर्मूला है हमारे पास, so there are several problems we need to solve based on the formulas. So when we are solving problems, we must remember the sign convention, and I'm dead sure that you are aware of the sign convention. So if we are taking distances to the right of the lens, so we have to take the sign positive, always positive. And if we are taking distances to the left of the lens, then it has to be negative, is it? And when we go upwards, it is again positive, and when we go downwards, it is negative. Okay, so these are the sign conventions you must remember while solving problems. They will not give you the correct signs of the values in problems. Okay, depending upon position of the object or the image, you must change the signs accordingly. Okay, so here you have to take care of. Now lens formula. See, lens formula is very simple. 1 by V minus 1 by U is equals to 1 by F. So what is V, what is U, and what is F? So U is the distance of the object. U is the distance of the object. V is the distance of the image, and F is the focal length, is called lens formula. Now U is the distance of the object, but from what? मतलब कहाँ से? From where? We are measuring distance, but we must know a reference point. So what it is? What is the reference point to measure the distance? Can anyone tell? You can tell in the chat box. मतलब हमें distance measure करना है. U is the distance of object. Let us suppose my object is here. Okay, here my object is. So मैं कहाँ से उससे distance measure करूँ? यहाँ से distance measure करूँ, या फिर यहाँ से, या फिर यहाँ से, या फिर यहाँ से? From where should I measure the distance? Okay, so it has to be measured from optical center or from O. Very good. It has to be measured from optical center. So like this, v is again measured like that only. This is the distance of image from optical center. And principal or focal length, we know that what is focal length, that is the distance between the principal focus and the optical center, right. Yeah, I understood, Bhairavi. Yeah, very good, you're correct. Yeah, very good. Okay, good. Now, magnification. The magnification due to lens is the ratio of height of the image to the height of the object. So, magnification के लिए formula क्या है हमारे पास? H2 divided by H1. Height of the image divided by height of the object. The magnification due to lens is also related to the distance of the object and that of the image from lens. So V by U. So these two are the formulas. Okay, so you must note down the formulas. You can write the formulas right now. So if you when you write the things, you remember the things for longer. Okay, so we have three formulas now. First one is this lens formula. Second one is this magnification formula by using height of the images and height of the object. And the third formula is again for magnification, but here we are taking distance of the image and distance of the object in consideration. Okay, now power of the lens. Power of a lens, the capacity of a lens to converge or diverge incident rays is called its power. The power of lens depends on its focal length. Power is inverse to its focal length. If f is expressed in meters, the unit of power is a length of a lens is diopter. Okay, so power of the lens is depending on, or it is inversely proportional to the focal length. If the focal length increases, power will decrease, and the power increases, focal length will decrease, like this. So again, remember the formula like this: 1 upon fm. Fm is what? It is a focal length, of the lens. So 1 diopter is equals to 1 by 1 meter. Again, this is unit conversion, you must remember. Combination of lenses. If two lenses with focal lengths f1 and f2 are kept in contact with each other, the combination has an effective focal length given by 1 by f is equals to 1 by f1 plus 1 by f2. So f1 and f2 are respective focal lengths of two separate lenses, and f is the combined effect or the combined focal length of these two lenses, like that. So here we have one example. An object is placed vertically at a distance of 20 centimeter from a convex lens. 20 centimeter from a convex lens. Now this is the distance of object. If the height of the object is 5 meter and the focal length of the lens is 10 centimeter, what will be the position, size, and nature of the image? How much bigger will be the image as compared to the object? So height of the object is given, that is h1 5 centimeter. Focal length is given. Distance of the object is given, that is 20 centimeter, but we are taking here minus 20 centimeter. Okay, we have seen the sign conventions. So image of the distance we have to find out, करना है. Height of the image find out करना है, and magnification again हमें find out करना है. So just put the formula: 1 by v minus 1 by u is equals to 1 by f. So v निकालना है हमें, u दिया है, f दिया है. Just put the values in the formula and you will get the v. V is what? V is the distance of the image from the lens. The positive sign of the image distance shows that image is formed at 20 centimeter on the other side of the lens. Okay, so image कहाँ पे form हुई है? Right side में form हुई है lens की. So can anyone tell what will be the nature of the image? Will it be real or virtual? It will be real image, Tanvi says. What do you think, other students? Answer quickly. Don't. Okay, real and inverted is the answer by Tanvi. Okay, real. Bhairavi, real. So may I ask the reason why it is real? Krish, can you tell the reason by turning on your mic? Why it should be real? Why it is a real image? Krish, can you turn on your mic? Yes or no? Just put in the chat box quickly. Don't waste your time, my time, and other students' time. If you don't know the answer, just put in the chat box, sir, I don't know. So that will save time for us. Okay. So obviously the reason is, if the distance is in positive, that means the image is on the right side of the lens, and when the image is on the opposite side of the lens, then it is a real image. Then it is a real image that we have already seen. Okay. So what we have to find now? Magnification. Magnification के लिए हमारे पास क्या क्या है? We have V1, sorry, V and U. We have V and U, as well as we have H1 also. मतलब हमें height of object पता है. So what we have to find out? We have to find out height of image, that is H2. So इस formula को modify इस तरह से मैंने कर लिया. See, H2 stays here, H1 is in denominator here, so it goes and multiplies V by U like this. So we have all three values. So we can find out H2 like this. So magnification will be -1. So the negative sign of the height of the image and the magnification shows that image is inverted and real, as Tanvi said. It is below the principal axis and is on the same is of the same size as the object. Okay, तो magnification कितना है इसमें? जीरो मैग्निफिकेशन, मतलब जीरो नहीं है, एक्चुअल में 1 मैग्निफिकेशन. मैग्निफिकेशन मतलब चेंज इन द हाइट ऑफ द इमेज, मतलब हाइट में कितना चेंज हुआ? कुछ भी चेंज नहीं हुआ. अगर -1 आ रहा है, इज इट -1 है, उसके ऑब्जेक्ट हाइट ऑफ ऑब्जेक्ट एंड हाइट ऑफ इमेज, इनका रेशियो अगर 1 है या फिर -1 है, डजंट मैटर, साइन यहाँ पे मैटर नहीं करता है. इफ इट इज 1, दैट मीन्स द इमेज इज ऑफ सेम साइज एज द ऑब्जेक्ट, इज इट? So these are the few things that we must understand while solving problems. Okay, we just don't have to remember the formulas and apply the mathematics. We don't have to do that. Okay, we have to understand the concepts. Now, the focal length of convex lens is 20 centimeter. What is its power? So it has to be the what I can say, easiest example. So what changes we need to do in the given data? That is, distance is given in centimeters, but we must convert it into meters for applying on this formula. So यहाँ पे focal length जो है वो मीटर में है. Okay, तो ये आपको ध्यान में रखना है. You must, मतलब एग्जाम में आपको सेंटीमीटर में focal length दी जाएगी, and if you put the value as it is, so you are gonna get a different answer. Okay, and that will be wrong. So you must convert the given data into the proper units, that is meters. So 20 meters is equals to 0.2 meters, and 1 divided by 0.2, that is equals to 5 diopter. Okay, so the power of the lens is 5 diopter. Now, human eye and its working of the lenses. So there is a very thin transparent cover membrane on the human eye. This is called cornea. Light enters the eye through it. Maximum amount of the incident light is reflected inside the eye at the outer surface of the cornea. There is a dark fleshy screen behind cornea. This is called iris. The color of the iris is different for different people. Like we know Hrithik Roshan is having green eyes. Okay, so your friend might be having eyes of different color. So yeah, it depends person to person. So there is a small hole of changing diameter in the center of the iris, which is called pupil. The pupil controls the amount of light entering the eye. If the light falling on the eye is too bright, pupil contracts, while if the light is dim, it widens. On the surface of the iris, there is a bulge of transparent layers. There is a double convex transparent crystalline lens just behind the pupil. The lens provides small adjustments of the focal length to focus the image. This lens creates real and inverted image of an object on the screen inside the eye. So two, three things in from this paragraph we must remember is that what is the use of cornea, then iris and the pupil and the crystalline lens. So important thing or the important part of all this is crystalline lens. Okay, pupil does what? It just controls the amount of light enters the eye. Okay, so it contracts or it widens, and this is how it just controls the light. But the main job of providing an clear image to us, to our brain, that is done by the crystalline lens. Okay, this is adjustable lens. So just you just want, if you want to play with your lens right now, so what you can do is you are now focusing on your mobile, right? Just try and look, थोड़ा सा साइड में देखिए, आपका कोई अगर दूर ऑब्जेक्ट है, so try to focus on that object. So when you are focusing on that object, just put your mobile in front of you and keep focusing on the object which is at distance from you. So you might observe that the mobile is now blurry to your eyes, but the object which is far away, that is clear to your eyes. Okay, so now I'm asking you to again bring your focus back to your eyes. Again bring your focus back to your mobile. Now your mobile is clear, but the object beyond mobile is blurry. Is it? Okay, so you can observe this simple experiment. बराबर, मतलब हम जहां पे फोकस कर रहे हैं, जहां पे हमें फोकस करना है, उस फोकस के अकॉर्डिंगली हमारी जो ये क्रिस्टलाइन लेंस है ना, ये उसकी फोकल लेंथ एडजस्ट करती है. ओके, इट एडजस्ट्स द फोकल लेंथ डिपेंडिंग अपॉन द position of the object. So this is how dynamic crystalline lens we have got. Okay, that is God gift, isn't it? A very amazing thing we have. So it adjusts itself automatically so that we can observe all the objects very clearly, is it? So there are certain what we can say diseases for this particular lens. So what are those? We are going to mostly see in the next class. Okay, so for before going to the next class, I just want you people to give one assignment. I want to ask you some questions as well. So we will continue from this, but first of all, just let me know, everyone, just please let me know what is schedule going on in your school. मतलब कि आपके स्कूल में भी फिलहाल क्या चल रहा है, whether your syllabus is completed, whether your practice tests are going on. Okay, exams are going on, so that must be practice exams, is it? Preliminary exams, yeah, prelims. Good, prelims. Okay, so everyone is having prelims in your school. Last lesson is remaining in your school. Okay, so Tanvi, your school is not having prelims as of now, is it? Okay, Bhairavi is again having her prelims. Okay, okay, 15 March, I got that. Okay, what about others? Om, Amar, Krish, Atharva, Arshad. Okay, Om, sorry. Arshad, you haven't typed a single word in the chat box. Okay, I'm going to remember this. I'm going to report this to Santosh sir and ma'am. Okay, everyone is responding except you. You haven't typed a single word. I noticed that. Okay, तो prelims चल रही है बाकी लोगों की. Okay, good. ठीक है. So our syllabus is again completed. We will also try and sync with your schools. Like अगर आपका स्कूल में, for example, कल साइंस की टेस्ट है, so we will try to keep science test in our class as well. Okay, so that आपको अलग अलग स्टडी नहीं करना पड़ेगा कि अगर क्लासेस में हमारे इसी सब्जेक्ट की टेस्ट है एंड स्कूल में इस सब्जेक्ट की टेस्ट है, तो for what we should study. Okay, so yeah, I'll discuss with ma'am and sir and we'll see how your exams should be taken. Okay, so but one thing you must do and remember, that revision is important. Whether your prelims are going on, whether your classes are going on, whatever is going on in your school or classes, you must keep revising the things. You must keep revising the things. You must keep asking for doubts. Okay, so like that. So it is 8:46 already, and it's time up for us. So yeah, I was talking about the assignment. So whenever we take our next class, mostly on Saturday or next Monday, so I expect from you guys to just explain these few things like myopia, nearsightedness, hypermetropia, that is farsightedness, and presbyopia. Okay, so these 2-3 concepts you guys can prepare and you guys can present in this in the class. Okay, if you wish to. Okay, so you can prepare for that. So why I'm doing this? Because it's a good habit, or it's a good practice to elaborate the things to others. Okay, so इससे हम भूलते नहीं है. Yeah, I think you are enjoying this, whatever we are doing. This is not boring for you, I guess. So yeah, that's it for that's it for today, students. Okay, hope you will elaborate the things very good, in a very good manner, in the next class. So yeah, we'll see you in the next class. Bye bye. Have a good night. Yeah, bye.